Okay, good day. This is Math 140 College Algebra. I am Professor McCully. This is lesson 4-3 N behavior and the zeros of polynomial functions. Let's get right to it. So today we are going to use the leading coefficient test to determine N behavior. We're going to use zeros and multiplicity of zeros as sketching aids, and we're going to use technology to find the zeros of a function. So for me, whenever I am asked to describe the N behavior, this is how I write it. The leading coefficient test explores the function at extreme values. And what we're going to do, we're going to say as x goes towards infinity or as x goes to the right, we're going to determine what the function does. Does it go up or does it go down? And as x goes to negative infinity or as x goes to the left, does the function go up or go down? And I call this the polynomial shuffle. And if you were ever in one of my classes, you'd see me do that wonderful, most impressive dance that you'll ever see. But you online people will not get to see it. Sorry. That's the breaks of having this wonderful technology. But from that, we have 4 real possibilities. And so what we look at when we're talking about these polynomials is we're going to look at the degree of the polynomial and we're going to talk about the leading coefficient. So if the degree of the polynomial is even and the leading coefficient is positive, then we know something about the N behavior. We know that as x goes to positive infinity, the function is going to go up. F of x goes to positive infinity. And as x goes to negative infinity, that function f of x is also going to go up. F of x also goes to positive infinity. Now, there's a lot that can be said that's dependent upon the degree of the polynomial, but in general, we can't say a whole lot about what's going on in here. So I'm going to draw this in red because it could be a lot of different things. All we can really talk about is the N behavior. What happens as the x values get very big positively and the x values get very large negatively. All right. So if the degree of the polynomial is even and the leading coefficient is negative, what we can say is that as x goes to negative infinity, f of x goes to negative infinity. And as x goes to positive infinity, the function goes towards negative infinity again. So just something that we can talk about here is that if the degree is even, the N behavior is going to be in the same direction for both as x goes to negative infinity and as x goes to positive infinity. Again, we cannot say a whole lot about what happens to the function near the origin. All we can really talk about is the N behavior. So we've done the 2 instances where the degree of the polynomial was even. And now we're going to talk about the 2 instances when the degree of the polynomial is odd. All right, so we still have those 4 possibilities. We've already done 2. If the degree of the polynomial is odd and the leading coefficient is positive, then we can say as x goes to positive infinity, the function value is also going to go to positive infinity. And as x goes to negative infinity, the function value is going to go to negative infinity. And just like in the other ones, the first two, I cannot say a whole lot about what's going on here. I don't know. Does it go through once? Does it go through 2 times, 3 times? I don't know. The leading coefficient test does not tell us anything about that. All right. And the final possibility, if the degree of the polynomial is odd and the leading coefficient is negative, then as x goes to positive infinity, the function f of x is going to go to negative infinity, and as x goes to negative infinity, that function is going to go up, or f of x goes to positive infinity. And again, I cannot say a whole lot about what goes on in the middle, but I can say something about the end behavior. Moving on, the zeros of a polynomial. A zero of a polynomial is a value of the independent variable that makes the function equal to 0. That is a generic way of saying an x-intercept, and I'll show you what that means. Well, let's do that right now. And so let's talk about right here. This right here, I don't know what the x value is, but because it is on the x-axis, I know that the y value is equal to 0. And so what that means through direct substitution, if I take this a value and I plug it in for x, I will get 0 out. That is what the zero of a polynomial is. It is a value for x that when you plug it into the function, you get 0 out. The multiplicity of a zero. The multiplicity of a zero is the number of times that the zero occurs as a factor of the polynomial. Note, multiplicity affects how polynomial interacts with the x-axis. For repeated factors, so if I have some factor x minus c to the k power, if k is odd, then it crosses, and I got some asterisks there because it depends on what type of odd number, and it crosses the horizontal axis at C0. If k is even, then the graph touches the horizontal axis at C0. The multiplicity of the zero is k. So let's take a look at some of these. Let's take a look at something like this. Let's just go to our y equals. Let's clear this out. Let's set up a polynomial function. Let's go x minus 2 times, and we'll write them as factors, x plus 3. And if let's hit zoom 6, just because we don't know. At x equals -3, -3 makes this factor 0. And so 0 times anything is still 0. That's why it's a 0. And x minus 2, when x is 2, that makes this factor 0. So we've got two zeros, one at -3 and one at 2. And based on this definition, both of the multiplicities is going to be 1. Why? Because the factor is only repeated one time. It's to the first power. And so what happens is, because the multiplicity is 1, it just goes through the x-axis and continues on, and it goes through the x-axis and continues on there. Well, what happens if I repeat this second factor? I make it x plus 3. Well, I could do that two ways. I could write x plus 3 again, or I could hit squared here. And so this factor has been repeated twice because I'm multiplying x plus 3 times x plus 3. This is now a third degree polynomial. And now when I hit the graph, at where it is repeated at x equals -3, it no longer goes through, it just touches the x-axis and then comes back down. And so if I go back to here, since k, this exponent here, was an even number, the graph is just going to touch the horizontal axis at C0, in this case -3. And the multiplicity is now going to be 2. So let's take a look. And I did that. All right, so if I want to use technology to find some real zeros, we're going to use the zero feature of the graphing calculator, and it is in a secondary menu of the trace function. And so what I'm going to do here is I'm going to show you, if you didn't already have this thing factored, I just don't want to put another polynomial equation in there. Let's say we wanted to find this 0, all right? What we're going to do is we're going to use this calc menu right here, which is the second function of the trace menu. Now, I've said this a couple times before, but I don't know why these aren't reversed, because all the good stuff is in this calc menu. Trace is never good enough in any of my classes. So if we want to find a 0, we're going to hit second, and then we're going to hit that trace button to bring up the calculate menu. And you see some really cool things here. So in this college algebra course, we're going to use the value, the zero, the minimum, the maximum, and intersect. If you ever get to calculus, you may use this dy over dx or this integral f of x dx. But we want to find the zero of the function, so clearly we're going to use 2 there. And the way that you do that is you'll see that it's x equals 0. I get negative 18 here. If I hit the right arrow key a couple times, I get my little spider guy to bop up there. And so this says left bound, so I'm going to hit enter here at the left on the left. I'm going to hit there on the right, so I can hit enter. And we're just going to hit enter a 3rd time, and we see 2, 0. But again, we already knew that that was a 0 for this particular function. So that's how you do it using the graphing calculator. Again, it is at second trace, and the number 2 is the 0 function. All right, moving on. It says describe the end behavior of the following function. So we're going to go back up to this slide right here. And so whenever you're asked to do end behavior, you're going to start with this, and we're just going to fill in the blanks for this f of x and this f of x. So when we're asked to do end behavior, we say as, oops, I don't like red, it's too big. As x goes to positive infinity, f of x goes to something that we're going to fill in, and as x goes to negative infinity, f of x has to go to something, and we're going to fill that in. Okay, so when I look at this, my degree is 3, and that is an odd number. And my leading coefficient is also 3, and that is positive. All right, pops. I don't know what that means. It's positive. And so since the degree is odd and the leading coefficient is positive, I see the degree is odd, the leading coefficient is positive. So as x goes to positive infinity, the function goes up, which is to positive infinity. And as x goes to negative infinity, the function goes down, which is negative infinity. So I'm just going to fill those in. So as x goes to positive infinity, the function goes to positive infinity. And as x goes to negative infinity, the function goes to negative infinity. That is going to be my answer for this particular problem. Okay, final example. It says find the zeros of the function algebraically. Use a graphing calculator to verify the zeros, and then we're going to determine the multiplicity of each zero. So first thing I'm going to try and do to find the zeros is I'm going to try and factor. And since I'm trying to factor this thing, I'm going to try GCF first. And when I look at this thing, I notice that there are x's in each term. So I look for the greatest common factor of x to the fourth, x to the third, and 20x squared. And I notice that x squared is the greatest common factor of both of those things, or all 3 of those things. That'll leave me with x squared minus x minus 20. So I have a quadratic here. And I think I can factor the quadratic. And so let's see here. I need 2 factors of negative 20 that add up to negative 1. That's pretty easy. Negative 5 and 4. Negative 5 times 4 is negative 20. And then negative 5 plus 4 is negative 1. So that's going to work. Give me x squared. I got x minus 5. And then x plus 4. And that is my factorization. And so algebraically, my final answer to A is x equals to 0 for this thing. What makes x squared 0? 0 does. What makes x minus 5 equal to 0? Well, 5 does. And what makes x plus 4 equal to 0? Well, negative 4 does. So that is my answer to part A. If I go to my graphing calculator, go to my y equals, I clear that out. I go x raised to the 4th, hit my right arrow key, go minus x raised to the third, and then I go right arrow, minus 20x squared. I hit graph, and we want to find the zeros here. So my first zero, let's see here, second, calculate, 0, so 2. I want to find this first 0. Minus 53. There we are. We're above. Looks like I'm not going to get to see my little spider guy. There he's above. And I know he's above because I get y equals 13. 13's off my window. I'm going to hit enter there. I'm going to go below, hit enter there. And we see that negative 4 is a 0. And sometimes you get an issue when you have a 0 that is, it just touches, because they're looking for where it crosses, and when it just touches, sometimes it gives you some problems. So let's see if we get an error here. And I hit error. There's no sign change, so it doesn't actually cross the x-axis, and that's what it's looking for. So that one we're not going to be able to find with the graphing calculator, but we already know what it is, so we're okay. So we're just going to quit here. And I'm going to second trace, and I'm going to do 0. We're going to get that last 0 though. And here he comes, negative, 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 get smaller. There it is. So there's my negative 31, hit enter, go to the right a little bit, hit enter, and there's my 0 at 5. So those are all confirmed. And so part C, determine the multiplicity of each. So part C, I'm going to say the 0 and the multiplicity. All right, so the 0, first 0 is 0. Its multiplicity, since it's raised to the second power, is 2. 5 has a multiplicity of 1, and negative 4 also has a multiplicity of 1, since it's also raised to the first power. All right, that's all I got for today, folks. So, the Marvel fun fact of the day: Winston Duke and Lupita Nyong'o stars as M'Baku and Nakia in Black Panther from 2018. They also attended the Yale School of Drama together and star in Jordan Peele's horror movie Us, which was released in 2019. Very creepy flick as well. That's all I got today, folks. Have a great day. Bye.